The binomial distribution gives us another method for calculating probabilities, but only in the event that we can identify an experiment as being a binomial experiment, meaning there are three very specific conditions our scenario has to meet in order to apply this approach. First, our experiment has to have exactly two outcomes. Second, we need to have a fixed probability of success on each trial. And we need to have a fixed number of trials. We'll look at an example here with a few different scenarios where we verify whether or not those conditions are met to give us an idea of how we identify where things might fall short. In part A, we have a golfer who practices putts from 1 foot, 2 feet, 3 feet, 4 feet, and 5 feet. A success is defined as making the putt. In this case, no, this is not a binomial experiment because the probability of success is not the same with each trial. As we get farther away from the hole, it should be harder and harder to make that shot. So since that likelihood of getting that putt in is changing, the probability of success is not fixed. In part B, a baseball player is practicing pitching. He throws pitches until he gets 50 strikes. So no, this would not be a binomial experiment because the number of trials is not fixed. If he was just going to throw 50 pitches, that would be a fixed number of trials. But if he's going to throw until he gets 50 strikes, that could be 50 pitches, that could be 1,000 pitches. There's no way of knowing. In part C, a game designer rolls a pair of dice 100 times and counts the number of times the sum is at least 10. For this to be a binomial experiment, we need exactly two outcomes, which we have in this case. Either the outcome that he rolls is 10 or larger, or something less than 10. There's more than one way to get those results, but there are two different outcomes. The probability of success in this case is fixed because every time you roll the die, there's the same probability of getting those different results. And the number of trials needs to be fixed, which in this case it is, because he's going to roll those dice 100 times. Since this scenario meets all three of those requirements, yes, this is a binomial experiment, and the methods that we're going to talk about in this section could be applied. In part D, a statistician stops 20 college students at random outside a dining hall and notes their class year. In this case, no, this is not a binomial experiment because there are more than two outcomes. For instance, degrees could include math, biology, and English. We already have more than three, and this is about their year in class. So first year, sophomore, junior, senior, we've got at least 4 ways people could respond. So we have more than two outcomes, doesn't meet the conditions for being a binomial experiment.